System archetypes represent commonly seen patterns of behavior in a system. They have regularly seen arrangements of causal relationships between the system's parts and feedback loops that lead to similar observable outcomes over time. As an illustration, we can think about the general dynamic of unsustainable behavior seen in a wide class of systems due to negative externalities. When a system has internal negative synergies between the parts, this creates negative externalities, entropy that is exported from the system. For example, an old machine whose cogs and parts are no longer running smoothly will create a negative externality of noise pollution. These externalities then typically build up in the system's environment to render the environment degraded and, over time, not able to support the system, which leads to a sustainability crisis. Climate change is one example, but there are many others, such as a financial crisis created by the buildup of toxic assets in the system. Another generic system archetype is a balancing process with delay. This archetype explains the system in which the response to the action is delayed. If the members do not perceive the delayed feedback, they might overshoot or underestimate the required action to reach their goals. This could be evaded by being patient or by hastening reactions of the system to realized measures. Each archetype has a characteristic theme or storyline, pattern, and potential for action. Being able to identify system archetypes in various situations enables a deeper and quicker understanding of that system, and could also help us design powerful intervention strategies. The following system archetypes describe the most common generic structures. The limits to growth pattern is one of the most well-known. It represents a period of unprecedented growth produced by a reinforcing feedback process until the system reaches its peak. The cessation of this growth is caused by limits inside or outside of the system. However, if the limits are not correctly identified, the previous actions are continuously applied, but more and more assertively. This results in the opposite of the desired state, a decrease of the system. The solution lies in the reduction or removal of the cause of limitation. This system archetype consists of two balancing loops or processes. Both are trying to correct the same problem symptom and bring the system back to balance. The above circle represents the quick fix symptomatic intervention. It often solves the problem symptom rapidly, but only momentarily. The bottom circle, which has a delay, represents a more fundamental response to the problem. Although the effects of the latter normally will take longer to become evident, the fundamental solution will have a far more effective outcome. Shifting the burden structures are common in our lives as well as in organizations. In these situations, obvious symptoms of problems attract attention, which often is dealt with by quick fixes that make the symptoms reduced, at least for a while, but they reappear again later. Imagine a lake in rural Kenya where everyone is allowed to fish. The lake doesn't belong to anyone in particular, and you can fish as much as you want. Imagine that there are two fishing companies in the area and that all those who fish in the lake belong to either Company Z or Company X. The more fish Company Z catches, the more profits they generate, and the more they will increase their fishing, as profits allow the company to hire more fishermen and buy more fishing boats. This principle is the same for Company Y, and together both companies make up the total fishing. In the beginning, both Company X and Company Y make good profits and provide a valuable service to the community. However, when we look at the longer term, we see that this system, if left uncontrolled, may result in some unintended consequences. If the level of fishing is not limited in some way, then it may eventually lead to a situation whereby more fish are being caught than are being naturally replenished, leading to a decline in the number of fish in the lake. Less fish in the lake, in turn, leads to more effort to catch a fish, as fishermen might need either better boats to go to deeper waters or to spend more time fishing to catch the same amount of fish. This decreases the profits of both companies, as well as the fish provided to the community. It also harms the fish population and perhaps the whole lake ecosystem. This describes a dynamic where two people or activities require the same limited resources. As one of them becomes more successful, more resources are assigned to them. However, now the second one becomes less and less successful due to lacking resources. This proves the right decision to support the first one. Problems arise if the competition is unproductive and interferes with the goals of the whole system. The two activities or agents might be decoupled, or they should receive a balanced amount of resources. Examples may be seen with a company that has two products, giving success to the one that was initially successful. These are all recurring patterns seen in systems mapping. By understanding the generic underlying dynamic, we can quickly use it to map out another system that exhibits similar behavior or symptoms.